Hi everyone. In the last video, we were classifying matter into physical and chemical properties as well as physical and chemical changes. In this video, we're going to focus more on elements and compounds as well as mixtures. So let's start with elements and compounds. Any sample of matter that has the same physical and chemical properties throughout the sample is called a substance. And there are two types of substances. We have elements and compounds. Now, an element is a substance that cannot be broken down into chemically simpler components. So, for example, if you've seen the periodic table of the elements, all of those elements cannot be broken down into simpler components. As an example, we have helium up at the top here. So this is an element, it's a gas. We use it in balloons, for example, and this is the simplest it can be. We cannot break it down further or split it apart, for example. Now, on the other hand, we have compounds. Compounds are substances that can be broken down into simpler components, and that's because it consists of more than one element. So a good example is water, which is H2O. So water consists of 2 hydrogen atoms and 1 oxygen atom. And we can actually do a reaction that splits apart the hydrogens from the oxygen. Now, this is a very difficult reaction to do, but it is possible, right? So this is a compound. All right, so let's see if we can identify the following as either an element or a compound. So I'll let you pause the video, work on this on your own, and when you're done, you can unpause and we'll go over it together. All right, let's start with the first one, CO2, carbon dioxide. Is that an element or a compound? Well, we have two different things here. We have carbon and 2 oxygens. And it's okay if you don't recognize these symbols just yet. That's why I also put the name next to the symbols. We'll learn more about that later. But carbon dioxide is a compound because it contains more than one thing. What about the next one, nickel? Well, nickel is just nickel. It can't be broken down any further, so this is an element. And the next one, aluminum, is similar. It can't be broken down, so it will be an element. And then the last one, CH4, is that an element or a compound? Well, it looks like we have 1 carbon and 4 hydrogens. So this is a compound. But again, even if you don't recognize those symbols there, we can see that there's more than one thing, so it can be broken down into simpler components. And again, we'll learn all of the symbols for the elements later, so no need to worry about that just now. Now, there is another way that we can describe these compounds or elements, and that's in terms of atoms and molecules. So the smallest part of an element that maintains the identity of that element is called an atom. So, for example, earlier we saw the example of helium, which is an element. Now, normally there isn't just one single helium, right? We usually have a bunch of helium. And if we were able to just isolate one single helium, that would be an atom. I also have the example over here of these bars of gold. Gold has the symbol AU. And if we were able to cut up that gold into smaller and smaller and smaller pieces, eventually we would get to the smallest piece of gold, which is the atom of that element. So for example, if we could zoom in on gold, we would see these tiny little gold atoms within that bar of gold. And then the smallest part of a substance that maintains the identity of that substance is called a molecule. So, for example, if we took an ice cube and chopped it up into smaller and smaller pieces, eventually we would get to the smallest part of that substance, which is a molecule of H2O. Now, the terms compound and molecule are sometimes used interchangeably. So if you see the word compound or the word molecule, typically they're referring to the same thing. So sometimes that can get a bit confusing, but try to bear with me here with all these different terms. Now, there is another way that we can describe molecules, because sometimes molecules will have 2 atoms, sometimes they'll have 3 atoms, etc. So let's say that you have a molecule that does contain just 2 atoms. One example is nitrogen gas, N2. So nitrogen is given the symbol capital N. This would be described as a diatomic molecule because it contains 2 atoms. So the prefix di means 2. But then let's say we have something like water, which is H2O. So that contains 3 atoms, 2 hydrogens and 1 oxygen, so 3 atoms total. That would be called a triatomic molecule, where tri means 3. And then we get into molecules that have more than 3 atoms. So sugar, for example, off to the side here, this is a ball and stick model of sugar. And you'll notice that there are different colors for each of the atoms in this molecule. So the black circles are carbon atoms. The red circles are oxygen atoms. And the white circles are hydrogen atoms. So sugar contains multiple atoms, right? It has a lot of atoms in it. We just call this a polyatomic molecule because it has more than 3 atoms. So poly just means many. So again, another way to describe molecules if you want to be very specific about how many atoms are in that molecule. Now, yet another way that we can describe molecules, let's say we look at nitrogen again, N2, so it has 2 nitrogens. Those atoms are the same type of atom, right? So we would call this a homoatomic molecule. So homo meaning same. But if we look at water, earlier we said this was a triatomic molecule because it had 3 atoms in it. But those atoms are different, right? We have hydrogens and oxygen. So we call this a heteroatomic molecule. Oops, I forgot the O in heteroatomic. So hetero just means different, right? So we have different types of atoms in our molecule. All right, so now that we've talked about molecules and atoms, let's talk a little bit about mixtures. So if we have a material that's composed of 2 or more substances, we call that a mixture. And there are actually 2 types of mixtures. We have heterogeneous mixtures and homogeneous mixtures, which is sometimes pronounced homogeneous. So either way you pronounce it is fine. But if we look at heterogeneous mixtures first, remember earlier we said that hetero means different. So heterogeneous mixtures contain obvious combinations of two or more substances. So that could be sand and water, or down below I have a mixture of vegetables. So we can very clearly see the different components of that mixture. But if you have a mixture that looks very consistent or uniform throughout, we call that a homogeneous mixture or a solution. There's all these different terms that we can use. So for example, let's say we blend up some bananas and apples and we get this smoothie over here. So just looking at the smoothie, it looks like it's just one thing. We can't see the individual pieces of banana. We can't see the individual pieces of apple. So it looks like it's just one component, but it's actually made up of multiple things. So this can get a little confusing, right? But with homogeneous mixtures, we often have to do further experiments to figure out what those different components are if we don't already know. All right, so let's practice identifying heterogeneous mixtures versus homogeneous mixtures. So feel free to pause the video and try this on your own first, and then when you unpause, we'll go over it together. All right, let's look at the first example, a pepperoni pizza. So would that be a heterogeneous mixture where we can see the different components? Or would it be a homogeneous mixture where we can't see the different components? Well, on a pepperoni pizza, we can very clearly see the cheese, the sauce, the crust, the pepperonis. So this would be a heterogeneous mixture. What about a milkshake? Can we see all the different components in a milkshake? Well, if it's blended super well, then no, we can't see the different components, right? So this would be a homogeneous mixture. What about spaghetti and meatballs? Well, that would be a very obvious heterogeneous mixture, right? Because we can see the spaghetti, the sauce, the meatballs, they're all very clearly different. So this would be heterogeneous. And what about tea with sugar that's dissolved? Well, if the sugar is well dissolved, we won't even be able to see it in the tea. So this would be a homogeneous mixture. So the tea would just look uniform, right? All right, so hopefully that helped with understanding the differences between a heterogeneous mixture and a homogeneous mixture. Now, there is one other way that we can describe matter, and we've kind of already talked about this a little bit, but we can describe matter in terms of the matter's state or phase. So that could be a solid, a liquid, or a gas. So looking down below, a solid has a fixed shape and volume. So we can see here this cube has a very definite shape and a very definite volume. A liquid, on the other hand, will take the shape of its container, and it has a fixed volume, so we can very easily measure the volume. And then finally, a gas is going to expand to fill whatever container it's in. So it does not have a fixed shape and it does not have a fixed volume. And we can also affect whether matter is in the solid state, the liquid state, or the gas state by changing its temperature. So, for example, let's say we start with water, which is a liquid at room temperature, and let's say we decrease the temperature. If we decrease the temperature, we're going to freeze that water and turn it into a solid. But what if we increase the temperature of water? Then it's going to evaporate into a gas. Now, let's say we actually start with gas and we want to cool it down. It's going to then condense into a liquid. Now, what if we start with a solid, like an ice cube, and we increase the temperature? Then that ice cube's going to melt and turn into a liquid. So you're probably very familiar with evaporation, condensation, freezing, and melting, but you can actually skip the liquid phase entirely in some cases and go straight from a solid to a gas, or vice versa. So a really good example of this is dry ice. If you've ever used dry ice, it's solid carbon dioxide, and it can make really cool effects. So like at Halloween, if you want to make a spooky scene, you can just use dry ice and it'll turn straight into a gas from a solid. So kind of fun to use. And most grocery stores sell dry ice, so you can always find it there. But the solid turning straight into a gas is called sublimation. And then let's say we wanted to turn that gas back into a solid and skip the liquid phase. That would be called deposition. Of course, deposition just makes me think of like lawyers and courtrooms, but that's also a term for a gas turning into a solid. And we'll talk more about these states of matter and these changes later on. So let's summarize all of the different ways that we classified matter so far. So if we start at the top here with our substance, we can first ask ourselves, is there only one substance present? If the answer is yes, then it's either an element or a compound. If the answer is no, then it's either a homogeneous mixture or a heterogeneous mixture. Now, obviously, in some cases, for instance, with the homogeneous mixture, it might fool you into thinking there's only one substance at first, so that might require more investigation to see if we do have a mixture or if we just have an element or compound. And then we saw that we can further describe the phase of these different categories here. So we could describe the phase as a solid, liquid, or gas. All right, so I think we'll stop here for this video. In the next video, we're going to talk about units. So how do we describe the volume or the mass of something, for example? And then we'll talk about density a little bit more. So I will see you then.